Today I am going to derive the expression for gravitational potential at a point due to a body. Gravitational potential already defined. Gravitational potential is the work done in bringing, in moving, in taking unit mass from infinity to a point in the gravitational field. Today, I am going to derive the gravitational potential. Now, title is Gravitational Potential at a point due to a body. Gravitational potential at a point due to a body. Here, now the a body of mass capital M is placed at O point, due to which there is a formation of the gravitational field, in which the P point is situated at the R distance from the point O, where the gravitational potential V is to be calculated, V is to be determined. Now here again, I am repeating the statement again. Now here, let us consider a body of mass m, which is called source mass. Source mass is the mass due to which the gravitational field is produced. Now, this body is the source mass. So let us consider a body of mass capital M placed at the O point, due to which the gravitational field is produced, in which the P point is situated at R distance from point O, where gravitational potential is to be determined. Is to be calculated. Now let us consider another point. Which is at X distance from point O, where the 1 kg mass is kept. In order to define the intensity of the gravitational field, intensity of the gravitational field may be defined as the force experienced by unit mass at a point in the gravitational field. Force experienced by unit mass. That's why the 1 kg is kept to derive the intensity of the gravitational field. Now let us consider the another point A, which is situated at the distance x from the point V, where the 1 kg mass is kept. First of all, you are going to give the expression for intensity of gravitational field. Intensity of gravitational field in intensity of gravitational field at P at A point, not P point. Intensity of gravitational field at A point किसके चलते? Due to the body of mass capital M, comma I equals gm upon x square. Intensity of gravitational field at A point due to this body, gravitational intensity of gravitational field, या कहिए gravitational field intensity, आप कह सकते हैं intensity of gravitational field at A point due to the body of mass m. इसे अगर हिंदी में लिखना हो तो क्या लिखा जा सकता है? ये m द्रव्यमान के पिंड के चलते, m द्रव्यमान के sorry, because now the English batch is going on, not in Hindi. No need of speaking Hindi or writing Hindi. Now the English medium batch is going on. Sorry. Now the intensity of gravitational field due to the body of mass capital M, comma, I equals gm upon x square. Then the intensity of gravitational field at a point. Now the intensity of the gravitational field at a point due to this body, that is the source mass of mass m, is I equals gm upon x square. It was already explained yesterday. Now gm upon x square directed towards O point. Directed towards O point. Now the equation first here. Directed towards O point. Intensity of gravitational field is directed from the right to left. From right to left. From A to O. Direction of gravitational field from A to O. Now, it is directed from right to left. Now, the work done, gravitational potential is nothing but the work done. Work done in bringing unit mass from infinity to a point. But here, now the work done in bringing the unit mass from A point to B point. A point to B point and covering the small distance dx. X, the smallest value of x is dx. Work done in bringing unit mass from A point to B point. Here it is clear. And the intensity of a gravitational field is also directed from right to left. And displacement is also directed from A to B, means right to left. Both are in the same direction. The intensity of gravitational field is directed from A to O, and displacement is also directed from A to B. Both are in the same direction. Therefore, now the angle between the two, I and dx, is 0 here. Now, again, I'm repeating the statement again. The work done in bringing unit mass from A point to B point, that is the work done. Displacement is a smallest. Therefore, work done is a smallest. A smallest part of x is dx, and the smallest part of work w is tw. Then here, the work done in bringing unit mass from A point to B point, that is the work done, dw equals I factor dot dx vector. We know dot product of A vector dot B vector equals AB cos theta. Dot product of A vector dot B vector equals AB cos theta. Therefore, here, now the dw is now the work done is the dot product of the force and the displacement. The displacement I is also the force. Because for unit mass, if the mass is greater than 1 kg, if the mass is greater than unit mass, then we can write the dot product of the F vector dot ds vector. But in the case of the unit mass, I vector dot dx vector, because intensity of gravitational field is also force. Intensity of gravitational force is force. Intensity of gravitational field is actually the force experienced by unit mass. Therefore, here in the place of the force, now the I vector is written on the board. It is clear from this expression, I vector dot ds vector, I vector, A vector dot B vector is equal to AB cos theta, dot product. Here is also the dot product, I vector dot ds vector. I. Now the A vector, I vector in the place of A vector, dx vector in the place of B vector, I dx cos theta. Cos theta. Here now you can say from the figure that now the I vector and d vector, I vector and dx vector both are in the same direction. Like from right to I vector, from right to left, and displacement both are in the same direction. Both are in the same direction. Therefore, theta is 0. Therefore, theta equals 0 degree. Why the theta is equal to 0 degree? Because the intensity of gravitational field and displacement both are in same direction. Same direction kahe ya same direction. And cos I dx cos 0 degree and cos 0 degree equals 1. I dx cos 0 equals 1. Therefore, dw equals I dx. From equation first, the value of I equals gm upon x square. It is clear from the figure equation first. Value of I. dw equals the value of I from equation first. gm upon x square. G, gravitational constant. M, mass of the body due to which the gravitational field is produced, into dx. Now we can write like this. gm x minus 2 into dx. dw equals gmx minus 2, equation second. To follow the definition of gravitational potential, to follow the definition of gravitational potential, work done in bringing unit mass from infinity to point P. But here, now the work done in bringing unit mass from A point to B point. You have to change the limit. Now the total work done, it is a small work done, the smallest work done in bringing unit mass from A point to D point, covering the smallest distance, displacement dx. Now we have total work done in bringing unit mass from infinity to a point P, because the P point is situated in the gravitational field. We are going to derive the expression of the gravitational potential at P point. Therefore, the total work done in bringing unit mass from infinity to a point, the total mass, you have to use the integral calculus, definite integral, integration of total work done, integration of dw, integration of g m x minus 2 into dx from limit from infinity to point P. P point is situated at the r distance. The lower limit or a minimum limit is infinity, and higher or the maximum limit is the P. P is situated at the r distance. It's clear from the figure here. Now the total work done. You have to derive the total work done. You have to use integral calculus. And not indefinite integral calculus, but you have to use the definite integral calculus here. Now the limit, lower limit from infinity to higher limit. What total work done in bringing unit mass from infinity to P point, and P point is situated at the r distance. The lower limit or minimum limit is infinity, and higher limit is a small r. It is clear now how to solve. You have to solve this expression here. Your definite integration should be solved easily. Integration of dw, integration of gm x minus 2 with respect to x. Again, you have to write here, or integration of dw, quantity G and mass of the body M are constant. They are outside the integration form here. Now, integration of x minus 2 with respect to x from infinity to a small r. From the formula, integration of x to the power n. Integration of x to the power n with respect to x, n plus 1, n plus 1. That is the expression for integration, whether it is indefinite or definite integration. In the case of definite integration, now the limits are important factor here. But in the case of indefinite, there is no limit at all. Now here, dx, integration of dx. 1 is missing, 1 is now here, 1 dx. You can write 1 here. Now the 1 dx equals 1 dx. And value of this, x0 equals 1, a0 equals 1, y0 equals 1. The value 0 of any quantity is 1. And 1, that is the x0, integration of x0. Here now the 1 is understood. Here 1 is now hidden in this question. 1 dx and 1 x0 dx. Then how to use the standard formula here, x0 plus 1, 0 plus 1 equals x. Finally, integration of dx is equal to x. Therefore, integration of dw is w. Integration of dx is x. Therefore, integration of dw equals w. And gm, now the definite integration limit from lower limit to higher limit, x minus 2, n plus 1, n plus 1. You have to write minus 2 in the place of n. Therefore, expression is x minus 2 plus 1 divided by minus 2 plus 1. Now, G is gravitational constant. Now, x minus 1 from infinity to r. Again, you have to write down here W. Gm x minus 1 from infinity to r. Gm x minus 1 the final expression here, dw minus g, x minus 1 means 1 by x from infinity to a small r, minus gm. First of all, you have to put the value of higher limit or a maximum limit in the place of x. And secondly, you have to put the lower limit, and the subtraction is to be taken here. For example, 1 upon r minus 1 by infinity. We know what is the value of 1 by infinity. 1 by infinity equals 0. 1 by infinity equals 0. Therefore, W equals minus Gm 1 by R minus 0. Therefore, final result is W minus Gm upon R, equation third. And this work done is nothing but the gravitational potential. This work done is nothing but the gravitational potential, because the gravitational potential is nothing but the work done in bringing unit mass from infinity to point P, which is situated in the gravitational field. Therefore, this work done is nothing but the gravitational potential. Here now, that is gravitational potential. V equals minus Gm upon R. V equals Gm. That is the final expression for the gravitational potential at a point P due to the body of mass capital M here. Now we are going to explain the gravitational potential energy. Gravitational potential energy. Gravitational. P dot E means gravitational potential energy. Gravitational potential energy. In the case of the gravitational potential, there is a slight difference between the gravitational potential and the gravitational potential energy. Gravitational potential, work done in bringing unit mass from infinity to a point in the gravitational field. In the case of the gravitational potential energy, gravitational potential energy is the work done in bringing certain mass. Mass should be greater than 1 kg. Certain mass, M mass. In the case of gravitational potential, 1 kg mass. But in gravitational potential energy, M mass, M is greater than 1 kg. In the case of the gravitational potential, work done in bringing unit mass from infinity to a point in the gravitational field. But in the case of the gravitational potential energy, work done in bringing certain mass means M mass. M is greater than 1 kg. Work done in bringing certain mass from infinity to a point P in the gravitational field. All the points are satisfied here. Only one point, except one point, from infinity in the gravitational field. But in the place of 1 kg, you have to use m kg. But only 1 kg, not 1 kg used for the definition of the gravitational potential, but the m kg is used to define gravitational potential energy like this. Now, 1 kg work done in bringing 1 kg from infinity to a gravitational at a point in the gravitational field is the gravitational potential. Shortly, it is written on the blackboard. You have to understand here, it was already explained. Now, the gravitational potential is the work done in bringing 1 kg from infinity to a point P in the gravitational field is the gravitational potential. Therefore, now the gravitational potential energy is the work done m kg from infinity to point P. That is the work done dW equals m into B. That is work done in bringing unit mass is the gravitational potential. But here now the work done in bringing m kg from infinity to P point in the gravitational field, that dW, m, that is the W equals m into V. W, m, value of V, minus Gm upon R. W equals minus m, a small, capital G, a small m, capital M upon R. And this work done is the gravitational potential energy. That is the gravitational potential energy, gravitational potential energy U equals minus G M capital M upon R. Gravitational potential is only gravitational potential V equals minus Gm upon R. But the gravitational potential energy U equals minus G small m capital M upon simply R. Gravitation again I am defining the here gravitational potential. Gravitational potential is the work done in bringing unit mass from the infinity to a point P in the gravitational field. But gravitational potential energy is the work done in bringing unit mass from not 1 kg but a certain mass from infinity to a point in the gravitational field. Again, potential difference. What is the definition of potential difference? This potential difference is called gravitational potential. Gravitational potential difference. DIFFERENCE. Gravitational potential energy. Yeah, simply potential difference. Potential difference. Gravitation potential. What is the difference between the gravitational potential and the gravitational potential difference? Potential difference. And first of all, gravitational potential. Work done in bringing unit mass from infinity to a point in the gravitational field. But in the case of the potential difference, work done in bringing unit mass from one point to another point. From one point to another point in the gravitational field. But in the case of the gravitational potential, one point is at infinity and second point is at P point. Now, the first of all, S.C. Verma has explained the potential difference. Now, the first point is A, first point, and second point is B. The work done in bringing unit mass from A point to B point, from one point to another point in the gravitational field. But in order to define the gravitational potential, A point is situated at the infinity and B point is situated at the P point. The potential difference, work done in bringing unit mass from A point, from one point to another point in the gravitational field. Now, you know the intensity of the gravitational field. You know the definition of the gravitational potential. Here, you are going to establish the relation between the intensity of gravitational field and the gravitational potential. Now, the last article of today is the relation between intensity of gravitational field and gravitational potential. In this, shortly it is written here. Shortly, relation between I means intensity of gravitational field and P gravitational potential. Very, very important. This article is very, very important. In the electrostatics, relation between the intensity of electric field and electric potential. And in magnet, relation between intensity of magnetic field and magnetic potential. Electrostatics is completely and magnetostatics are completely dependent on the gravitation relation between intensity of gravitational field and gravitational potential. Let us sketch the figure here. Now, the body of mass capital M, due to which the gravitational field is produced. 2 points here. two points A and B. Both points are situated in the gravitational field. Now, both are very close to each other. Here, now the B point is situated at R distance from O, and A point is situated R plus dr from the B point is at R distance from O point, while A point is situated at R plus dr from the point O. Therefore, difference between two points A and B, dr, the smallest value of R is dr. That means both points are very close to each other. Both points are very nearer to each other. Here now, in order to explain, both are far away from each other, but fact is that both are very close to each other. Therefore, the intensity of gravitational field between the two points is I remains constant between A points and B point, and it is directed from A to O. Now the intensity of gravitational field is directed from right to left. Now the intensity of gravitational field, both points are very close to each other. Therefore, this intensity remains constant between the two points. Yeah, I, and it is directed from right to left. Right to left here. Now the gravitational potential is minus V. Gravitational potential is zero at infinity. But a point in the gravitational field is negative. The gravitational potential at A point is minus V, and gravitational potential at B point minus V plus dV. V plus dV. Therefore, potential difference between the two points, potential difference, potential difference between two points, minus V plus dV minus V. The potential difference between the two points, work done in bringing unit mass from the A point to B point, or just simply difference of two potential is the potential difference. It was explained in the 10th class. Difference of potentials between two points. The potential difference of potential of two points, B and A, minus V minus dV, minus V minus plus minus plus minus V plus V is cancelled, minus dV. The potential difference between the two points A and B is minus dV. Minus dV, and the relation is potential here. Potential difference. Here, potential difference between two points is the work done in bringing unit mass from A point to B point. Again, we are going to use the work done. Now, the work done is the potential difference by the potential difference minus, first of all, potential difference. Potential difference equals work done in bringing. It is not written on the board, only spoken here. Now the work done, potential difference is the work done in bringing one point to another point, and is I into dr. No need of using dot product again and again. We can use the dot product here. We can again use the dot product of I vector, not dx vector, but dr vector. Both are in the same direction here. Again, you can see that now the intensity of gravitational field I and dr, now both are in the same direction. Therefore, theta is equal to 0, and the final result is I into dr, I into dx. In the last article, I into dx, but in this article, now the not dx but the dr. Now I into dr, again the potential difference is minus dv equals I into dr. We can use the dot product. I vector dot dr vector. Again, the AB cos theta. Theta is equal to 0. There is no need of the expand the notes here. Here now the only simple I into force into displacement, but here in the place of not F is written here because now the for mass M is F is used, but in the case of the intensity of gravitational field, because the intensity of the gravitational field unit mass is explained here. For unit mass, now the I for more than I 1 kg F into dr, force into displacement here, I into dr. Therefore, I equals minus dv upon dr. Here, I equals minus dv upon dr. That is the relation between I, and I is the intensity of gravitational field and V is the gravitational potential. Here, velocity gradient V upon R. Velocity gradient V upon R, but it is written in calculus form. Now dV upon dr, that is the velocity gradient. Now pressure gradient, pressure gradient, P upon R, but in differential form dP upon dr. Now here dV upon dr, gravitational potential gradient, here gravitational potential gradient V upon R, but in differential form, that is the dV upon dr. That is the gradient of gravitational potential gradient. Now the potential divided by R in the calculus form dV upon dr. Now here the intensity of the gravitational field is equal to gradient of gravitational potential gradient with negative sign. Here now the intensity of gravitational field is equal to negative gradient of gravitational potential. Now it is very, very important for 12th class. 12th class. In the case of magnet, the intensity of magnetic field equals dV upon dr. V is the intensity of magnetic field and V is the gradient of magnetic potential. And in the case of the electrostatics, the intensity of electric field equals minus dV upon dr. Now intensity of magnetic field is equal to now the gravitational, not gravitational, magnetic potential gradient with negative sign. Here, intensity of electric field is equal to the gradient of electric potential with negative sign. Or here is the intensity of gravitational potential is the gradient of gravitational potential with negative sign. Jai Hind. Good night.